I thank Etmel for providing me such a wonderful opportunity to showcase my talent and demonstrate my project in Etmel Design Contest 2015. Our team, comprising of myself, M. Gunadeep Reddy, K. Nagabaipu Reddy and Bhavadeep Reddy of ECE Department BVRIT, are here to demonstrate our project titled Eye and Gesture Based Automation. As the title suggests, eye and gesture based automation, the inputs from the user are taken in the form of hand gestures and eye gestures. Coming to the applications of this project, the applications are different in different kinds of fields, and they are applicable in medical field, and they are used in industry automation, and they can be released as a product in a commercial market and also used in the field of military. First, coming to the medical field. As the statistics suggest that there are different kinds of patients who suffer from different kinds of diseases. Example, the quadriplegia patients, tetraplegia patients and paraplegia patients. So, in order to communicate with the external world, these patients require the governance of an individual. So, our prototype is very useful for these kinds of patients. The patient can interact with the external world or perform his individual tasks using his hand gestures or eye gestures. A quadriplegia is a disease where all the muscle cells of the body are dead and only the eye muscle is alive, eye muscle and the head muscle. So, in this way, the quadriplegia patient can interact with the external world using eye gestures. And coming to the spinal cord injury patients and the patient who lost their legs in different accidents. So, for these kinds of patients, they can interact with the external world using hand gestures. So in this way, our prototype is useful for quadriplegia patients, spinal cord patients and victims of different accidents. Not only the medical field, it's also applicable to the industrial automation, where the workers have to deal with heavy machineries and have to deal with heavy power supplies. It may also lead to different kinds of accidents and can take the cost of their death. So, in order to reduce these kinds of accidents, the workers can deal with different kinds of heavy machineries using this gesture-based automation. So in this way, it's applicable to the industrial automation and can reduce the cost of the labor. Coming to the commercial market, we have different home automation systems which work on Android app and Bluetooth facility. But gesture-based home automation system is a different kind of technology where the user just uses his hand inputs to switch on the different home appliances. He doesn't need to wear any wearable electronics, and it's just only the single hand which is taken as an input from the user to switch on different home appliances. Coming to the field of military, the Russian army developed a system called head-mounted targeting device where the pilot driving the flight uses eye gestures to target the opposite flight, and in this way it's also used in the field of military. Let me explain the block diagram of our project. We are using Python as a programming environment and OpenCV as an image processing library, and we are also using numerical Python, which is NumPy module, and also we are using PySerial in order to establish a serial communication between laptop and the microcontroller unit. And coming to the block diagram, where the input is the human, where he'll be giving voice inputs, whether he need hand gestures or he need eye gestures. First, when we switch on the code, the the Python will be asking for a voice input, whether to switch on the hand gesture or the eye gesture. Based on the disability of the person or the application of use, the user mention hand gestures or eye gestures. If it's hand gestures, then the imaging device, which is nothing but the camera, will be switched on, and the respective hand gesture code will be processed in OpenCV, and the resultant output will be communicated to the Atmega 168PB microcontroller unit using serial communication. Based on the hand gesture inputs given by the user, the processing in CV is done and the serial communication is done with the Atmega 168PB, and the respective motors or LEDs attached to that pins are switched on, and in this way the hand gestures code will be working. And coming to the eye gestures code, again the human is asked for a voice input whether he need hand gestures or eye gestures. If he responds that he need eye gestures, then again the camera will be switched on, which is nothing but the imaging device, and again the processing in CV is done where the iGesture code is run at this time and the serial communication is taken place between Atmega 168PV and the Python, the third party application, and again the respective output pins are taken to the high state and the motors and the LEDs are driven on. Explain you about the flow chart or the flow diagram of our project. Coming to the flow diagram of our project, first the input of the user is taken by the imaging device, which is nothing but the camera. Before taking the input by the camera, the user should mention in the voice input whether he needs hand gestures or the eye gestures. If he will select hand gestures or eye gestures, then the video frames are saved in the form of image frames, and next each image is converted into grayscale image. First, the reason to convert it to grayscale image is the main image consists of RGB, three different types of colors, which is very difficult to process. If we convert it into grayscale, then the color complexity will be reduced and it's easy to process. Next, after applying the grayscale, the next step is applying the threshold. We need to apply the threshold by giving a particular value. If the pixels values are above the threshold value, then they are converted into black, and if the pixels values are below the threshold value, they are converted into white. So in this way the thresholding works, and finally we get a binary image. Binary image is nothing but which consists of only two colors, either the black or white. And in this way our recognized object, which is nothing but the hand or eye, is detected after the threshold image. Next we will be detecting the eye. After detecting the eye or hand, next we need to apply contours. Contours are nothing but the outlines of the images or the similar points of same color. Now after applying the contours, we need to find gestures. After finding the outline of the contours, we need to find hand gestures, which are nothing but used by convex hull method. Convex hull method is nothing but the convexity defects it will be checking. After applying the contours, which are nothing but the outline of the images, we need to find the gestures. There are different techniques to find the hand gestures, and we use Boyle-Legendre method to track pupil and convexity defect to track the hand gestures. What happens actually in the convexity defect? Actually, this is our hand gesture, and when the contours are drawn along the hand, this is the convexity defect. If we recognize one convexity defect, then it's recognized as two fingers, and if we recognize two convexity defects, then it's three fingers. In this way, the hand gestures are recognized. And Boyle-Legendre's method is used to track the pupil, which is nothing but the eye pupil, and the direction of the pupil is described using this algorithm. And after detecting the hand gestures and eye gestures, the next thing is bounding pupil and gestures in a rectangle box to track movement. After detecting, we should know the direction in which the eye gesture or the hand gestures are moving or what they are simplifying. So after we need to bound it in a rectangular triangle and find the directions in which the eyeball is moving. After that, based on the output of this, we will be connecting to the Atmega 168PV Explain Mini using serial communication, and this is done using a module called PySerial. PySerial is a module which sends data to the COM ports from Python, the third party application, to the Atmel Studio 7, which is used by Atmega 168PV, which is nothing but Explain Mini. And based on the output of the gestures and the eye gestures, the serial communication is done with the Atmel Explain Mini, and based on this, the respective output pins are switched high and the respective motors and LEDs are driven. And in this way, the patient or the user can use the hand gestures or eye gestures to satisfy his needs. Let me explain you the different units in my project. The first one is image processing unit and the second one is microcontroller unit, and we need to interface this both using serial communication unit. In the image processing unit, we use Python as a third-party application to program, and Python is the programming environment, and OpenCV is the image processing library used in image processing unit. And in order to take the voice inputs, we use microphone to take the voice inputs of the user and act according to the gestures. And this is up to the image processing unit. The different modules involved in image processing unit are: one is PySerial, which is used to send data to the serial port, and the other thing is OpenCV library, and the third thing is NumPy, which is nothing but the numerical Python which is to process different images using mathematical operations. And next, coming to the serial communication unit, which is nothing but the interfacing unit. This is done using a USB between Atmega 168PB and the PC, and the data is collected from the COM port provided by the Pi serial and sent from the USB to the 168PB, and this is up to the interfacing unit. And next, coming to the microcontroller unit, we have different outputs to be provided by the microcontroller unit. We used different digital pins as outputs, and the different components used in microcontroller unit are Atmega 168PB, a 12 volts battery in order to drive the motors, and LM293D, the motor driving IC, and an external LED, external buzzer, and the motor which will rotate according to the gestures and the direction. And this is up to the microcontroller unit. And the three sections, microcontroller unit, image processing unit, and the interfacing unit, comprises my project. And coming to the working of my project, first I should dump my code using device programming to the Atmega 168PB using device programming. Initially, the microcontroller pins are to be set high, so that's why the LED is glowing and the buzzer is making sound. Now, opening my Python third-party application, which is to take my voice input. I am running this program. Hand. The respective hand recognition, hand gesture program is running. Now I should show my hand gestures in order to rotate the motor. First, when I give the input 1, screen. First, when I give the input 1, I have provided but that nothing should happen. But when I give the input as 2, the motor is rotating in clockwise direction. And when I give the input as 3, the motor is rotating in anti-clockwise direction. And when I give the input as 4, the LED, onboard LED of Atmega 168PB is glowing, and also the LED of breadboard is also glowing. So in this way, the hand gestures is used to control different appliances. In the first part, I have explained you about the hand gestures, and I have mentioned you about eye gestures. Now I will be explaining you about eye gestures. The voice input will be asking for the input whether to open hand gestures or eye gestures. Eye. Now the respective eye gesture code is working. As we don't have high definition cameras to track eye, I made a prototype by tracking the ball and its direction. Now when I move the ball upwards, it's moving up. So you can see the word there, looking up. And when I move the ball downwards, it's moving ball down. And when I move it to the right, it's coming to looking right. And when I'm moving the ball towards the left, it's moving to the left. Think this ball as a pupil, and the movement with this ball is tracked as the eye movements. Now this movements helps in rotating the motors in different directions. Now I'll explain you how this will rotate the motors. As we know, the directions which the ball is moving will send different serial ports or the serial to this motor, and based on that the motor will be rotating. If I move the ball in different directions, the motor will be rotating in different speeds. Again, coming back to the code of ball gestures, the tracking of ball is done. And based on these directions, it can be used in different applications. As I have mentioned you, in the field of military, the eye gestures are used in measuring the direction of the missiles and to target the opposite object. In this way, the gestures of this will be detecting the motion of the ball and it will be sending to the serial port, and based on that the motors will be rotating.